All hello, happy days to all of you rock stars. Today we have a very important topic to talk about. We're going to talk about unit rates, and I'm excited to get into that. But I wanted to first figure out if you know what the difference between a fish and a piano is. You can't tune a fish. Tune a fish. Tune a fish. Tuna fish. All right, so today let's dive right into it. We're going to identify. This is a lot of words, but it will make a lot more sense once we get into it. Today, you're going to identify the unit rate of a proportional relationship presented by a table of values, a contextual situation, which is like a word problem, or a graph. And we're going to be thinking about how do we determine a missing value in a ratio table that's represented between two quantities and a unit rate. Like I said, blah, 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 blah. It'll make more sense because some of those phrases are new to you. Let's dive in and see what that means. Okay, so a unit rate, let's talk about that first. That's a comparison of two measurements in which one of the terms has a value of 1. So when you think of ratios, you think of the way you write them as 3 to 4 or 3 to 4 or maybe 3 to 4, right? So in unit rates, one of those numbers is always going to be a 1 because we're comparing these two values to 1. For example, if you look at the bottom, we have 42 marbles in one bag, 42 to 1. Down here we have 3 cats per one house, 3 cats to one house. It doesn't matter which one. It could be 1 house to 3 cats. It could be 1 bag to 42 marbles. It doesn't matter where the 1 is. It just means that one of them is a 1, so we're comparing something to 1. Okay, let's do a quick ratio review. Ratios are the comparison of two values, like you just saw in that vocabulary, cats to houses or boys to girls in a classroom or yada yada. For example, we compare the number of neighboring houses and the number of TVs and all those houses combined. So in these houses in a neighborhood, there may be 5 homes, and in those homes, they have 20 TVs. So our ratio would be 5 to 20. And you could say that for every 5 homes, there are 20 TVs. All right, just a quick ratio review. Now, let's talk about unit rates, and let's intro that. They are super duper useful in the real world. Super duper useful. Say that. Super duper useful. All right, and unit rates have one part of the ratio as the number 1, if you remember that in the vocab we just did. One part of the ratio is a 1. And you've seen and heard unit rates a lot in your whole life, but you probably, or maybe, just don't know that they are unit rates. If you've ever heard someone talk about the speed they're going, your mom was driving 45 miles per hour. That's a unit rate. She was driving 45 miles in 1 hour. Every 1 hour. That's 45 per 1. See the 1 involved there? So there's another way to write it as a fraction, 65 to 1, 65 miles in 1 hour. Costco and Sam do this all the time. They put cost per ounce on their price tags. So when you walk by, you'll see this big price, right? You'll see a massive bag of rice, and it may cost $8.35. And you just don't know if that's a good deal or not. So you go look at the price tag down in smaller font, and it'll say the price of just one of those ounces. So then you can get that big bag and say, well, if 1 ounce costs this, and I go get a different bag, different brand, and it's bigger, it has a different price, and you just want to know which one's the better deal. Find out the cost per 1 ounce. So they take them down to the unit rate so you can figure that out. All right, so let's talk unit rates. A unit rate describes how many units of the first quantity of a ratio correspond to 1 unit of another quantity of the ratio. So let's look at an example, okay? Let's say we know that 5 binders cost $10. You're walking into Walmart, you're in any store in the country that sells binders, and you see a sign that says $5 for 10 binders. Okay, so we can put it in a thing called a ratio table to try to figure out how to work with it. All right, so the ratio table has the top row of it shows number of binders, and the bottom of it says how much it costs in dollars. Okay, and so for our scenario right now, what we know is 5 binders cost $10. So we know that 5 binders cost $10. How much is 1 binder? In other words, what is the unit rate? So I'm trying to figure out how much 1 binder is. I'm trying to find out binder or cost per 1 binder. That sounds like a unit rate, doesn't it? So any ratio can be converted into a unit rate by writing the ratio as a fraction and then dividing the numerator and denominator by the value of the denominator. So That's a lot of mumbo jumbo too. Let's dive in. This may make more sense. Okay, so the big part about this is we have to figure out how to convert this into a unit rate. In other words, how do we convert 5 binders over $10 into a unit rate? So you can divide it, the numerator and denominator, by the value you want one of them to be. Okay, so let's try that idea and let's try that idea. For an instance, we have 5 binders that cost $10. Do we want to know how much binder we get for $1? Or do we want to know how much one binder costs? Right, we want to know how much one binder costs. So that's where we want to put our 1. We want to turn this number into a 1. So we'll have one binder costs a certain amount of dollars. And how do we do that? Well, good question. Okay, we're going to use our knowledge of equivalent fractions. Okay, and we know that in order to find an equivalent ratio or an equivalent fraction, we have to divide the top and bottom or multiply the top and bottom by the same number. So in this instance, we're going to divide by whatever number we want to turn into 1. So we want to turn 5 binders into 1 binder. So what we do is we divide the top and bottom, because that's the only way we find equivalent. We divided the top by 5, and we got 1. And we divide the bottom by 5, and we get 2. And that is our unit rate. So we can go ahead and put that into our ratio table. And now at this point, we can figure out any other value in that ratio table. Okay, all we have to do is figure out which one of these we want to turn into 1. So for example, if we wanted to turn the 10 into 1, we would have divided that, we would have said 5/10 divided by 10 over 10. All right, because then we would have turned the cost into 1. But in this case, we wanted to know what one binder would cost. So we divided the top, which was 5, by the 1. Okay, so now that we know the unit rate, we can easily fill out any other section of this table, right? Because of what we understand about equivalent fractions. So here's what we do. We take our 1/2, and then all of a sudden, like in a problem or an issue, you're trying to figure out, well, how much is 3 binders going to cost? Because I have, or I go to school this year and they told me I need 10 binders. How much is 10 binders going to cost? Well, if you know the unit rate, life is easy. So let's play with this. Let's say we got 1/2, okay? And we want to know how much 3 binders is. So we put this up and we put the 3 at the top because we're going from 1 binder to 3 binder. Okay, understand that? That's why the 3 is on the top of the next fraction. Okay, so here we go. What's next? We know in order to get from this 1 to 3, we multiply by 3. Remember, it has to be multiplication and division when you're dealing with proportions. It cannot be adding and subtracting. And we know with equivalent fractions, whatever we do to the top, we have to do to the bottom. So I multiply the bottom by 3 as well. Okay, so here's we're multiplying by 3 over 3, and that's going to give us our new ratio, okay? Or a new answer to our missing cost. So 1 times 3 is 3, and 2 times 3 is 6, all right? So we know that when we multiplied 1 times 3, we got 3. So now we have 3 binders. 2 binders times 3, 2, which is the cost, $2 times 3 gives us $6. So the 3 binders is going to cost us $6. All right, so then we can do the same thing with 10. All right, we went from 1/2 to 10. All right, so we multiplied 1/2. We multiplied the 1 times 10 to get our top. So we have to do the bottom the same way. Multiply them both by 10. And that gives us 1 times 10 equals 10, and 2 times 10 equals 20. So 10 binders cost $20. As long as you know the unit rate, multiply by 3, multiply by 3. Multiply by 5, multiply by 5. Multiply by 10, multiply by 10. Pretty simple, huh? So we can also use unit rates using double number lines. You may have never heard that before, but it's a pretty cool tool. Okay, let's do it in a word problem. To make a drink, I mix 1 liter of syrup and 3 liters of water. How many liters of syrup do I need if I have 15 liters of water? So the thing we're missing right here is how much syrup we're going to need if we're going to make this bigger portion of that. Okay? So let's use a double number line. All right, so here we go. Here's a double number line, and the way a double number line works is you put what you want to measure next to one of the number lines. So in that top number line, we're going to measure water. In the bottom number line, we're going to measure syrup. Okay, and the first question we ask ourselves is place the unit rate on the number line. In this case, we know the unit rate. All right, so let's go ahead and place the unit rate. We know how much water. Okay, water is 3 liters, and we know that the syrup is 1. So there's our 3 to 1. There is our unit rate. The next step is place the new ratio that you already know. We already know one part of this other ratio, right? It tells us that we have 15 liters of water. So we put 15 on the top because the top represents water. And then we do the same thing we did before. We look at it and say, what is left? What are we trying to find? In this situation, we're trying to find how many liters of syrup. So that's our variable. All right, syrup is what's missing. We need to know that value. So how do we do it? We use our proportional reasoning and equivalent fraction knowledge to solve. So what did I do to get from the 3 to the 5? Well, I multiplied by 5. And according to our proportional reasoning, the rate has to stay the same in a ratio in order for it to be proportional. And the same thing with equivalent fraction. Whatever I do to the top, I have to do to the bottom. Okay, so if I multiply the top by 5, I multiply the bottom by 5. What's 1 times 5? It is 5. Very good. And so our ratio is I need 5 liters of syrup to make this drink. That's the answer to the question. We can also use double number lines to find the unit rate. What if we have a scenario that doesn't give us a unit rate? In this instance, there's a teacher who ordered supplies to build rockets for his whole class. He ordered 60 rockets and he has 20 students. How many rockets will each student get to make? Okay, so let's set up our double number line. So here comes our double number line. We got to label each one. We're going to put students on the top and we're going to put rockets on the bottom. Okay, so in the double number line, place the values that you know. We have a ratio that we know. We know we have 60 rockets and we know we have 20 students. So let's put that in there. Okay, so we have 60 rockets is on the bottom and the rocket number line, and 20 is on the top and the top number line. Okay, then what do? We place the value of the unit rate that we want to make 1. We want to know how many rockets does each student get. So if we want to know each student, what we're saying is we want to know how the 1 is the students. We don't want to know 1 rocket. We want to know how many rockets each student gets. Okay, now we have to figure out what's left over as the variable, which is what's missing. Okay, it doesn't know how many rockets, so that's what's missing. And then we use our fractions and proportional knowledge to understand this. Okay, so now we're going backwards. So how did I get from 20 to 1? Well, you didn't multiply this time, you divided. 20 divided by 20 equals 1. And what do we know about fractions and proportions? Whatever I do to one, I have to do to the other. The rate has to stay the same. So if I divide the top by 20, I have to multiply, or I'm sorry, if I divide the top by 20, I have to divide the bottom by 20. And what's 60 broken into 20 groups? Well, it's 3. And so every kid, every student gets 3 rockets to build. Coolio. All right, so let's go ahead and fill in the blanks here. All right, always take a ratio and turn it into a blank when thinking about rate tables or proportions. So if you're trying to figure out other values on a ratio table or figure out proportions, go ahead and turn it into a unit rate. And I mean always. It makes your life so much easier. All right, second one is use blank fractions to solve any other values when dealing with unit rates. Equivalent fractions, right? Remember ratios, you can set them up like fractions, and proportions are the same thing as equivalent fractions, all right? They show the same value increasing at the same rate on the top and bottom. Okay, and when completing ratio tables with unit rates, this is important. We only use multiplication and division. So many times over the years as I've worked with kids on unit rates and ratio tables, they're like, oh, add 6 and add 6. That's not going to give you a proportional understanding. It's got to be multiplication or division. All right, I think you're ready to rock and roll with this one. What does a rabbit use to fix its fur? Hairspray. Hair, H-A-R-E. Peace out.